Hello and welcome back, guys, with another video. This is another PCS transmitter right here. This is the DDS transmitter. So as you can tell, from the outside, it looks pretty much identical to the last PCS transmitter that I reviewed, which was the QN8007 based transmitter. Which I believe you could technically call a DDS transmitter, although what I call it is an FMIC, okay, an integrated circuit, an IC, right, meaning it uses one chip, right, which is the QN8007, right, and that is generally the most budget, cost-effective type of transmitter, is the QN8007 type single IC transmitter. Okay, this one is the DDS transmitter from PCS. It's a very new product in their product line. I believe they just came out with their DDS transmitters like a few months ago. And so, it's a very new thing. And as you guys know, if you've watched my previous videos, DDS transmitters are the best. It's like you just do not get any better than DDS, right? It's the best kind of transmitter you can get because there is like no audio distortion at all, right? It's like it's exactly what you send into it is what you hear over the air, right? So the only downside that tends to happen with DDS transmitters is that they tend to be a bit noisy, okay? But the thing is that DDS, the technology has improved over the years, and, slowly it's just gotten better and better, and it's gotten to the point where, the noise floor has been reduced so much that it's pretty much as clean as a PLL VCO transmitter. See, in the past, during the beginnings of DDS transmitters, there was still a huge advantage to traditional PLL VCO transmitters in the fact that they had a very, very clean output, right? Much cleaner than the DDS, even though their sound quality was not quite as good, right? But nowadays, DDS is the best all around. It's like they've improved the technology to the point where, the signal is very clean, has very little spurious, and then also has the best audio quality, right? So in this video, we are going to be testing out PCS's, that's PCS Electronics, their new DDS transmitter, and this is their 15-watt model. And yeah, so I've got it hooked up to the spectrum analyzer right there, and we're going to do another test just like we did with the other PCS transmitter. I've got my 50-watt element here in Bird, and it's currently powered off. Everything is powered off but plugged in and ready to go. So let's give it a try. You can hear the fan. Alright, so here we go. So as you can tell, I believe this transmitter is a little bit more noisy than the QN8007. If I remember, I don't think the QN8007 transmitter was quite as loud. However, there is an advantage here. See, on this transmitter, they mounted the fan here as opposed to on the back. See, on the QN8007 transmitter, it's mounted on the back. But anyway, so yeah, this fan is a bit louder than, than usual. But it's not too bad. It's not prohibitive or anything like that. So we're set currently to 5.1 watts. That's 35% power on 87.9. So let's take a look. All right. Yep, that's looking pretty good. So let's give this a test here. I'm going to press this, and I'm going to adjust the power, and we're going to see what we get at full power here. We're going to see what we get at full power here. Okay, so that's reading 15.1. And, yeah, we're getting exactly 15 watts. Exactly 15 watts. This is absolutely perfect, as you can see. It's even better than the QN8007 one. It's exactly on point. So this is really good. This is really good. So, let's just do the same exact thing, except we are going to set the frequency to ensure that we get, you know, good power output at the high end of the band as well. So 107.9, okay? So this is 107.9. Alright, so looking good on there. Let's take a look. And, oh, wow, okay, we get an extra watt. We've got 16 watts. Okay, well, that's good. I mean, we've got 1 extra watt, and it says on the screen 15. So that's nice. So it looks like they're actually optimizing these transmitters for the high end of the band. But I mean, either way, it's very flat power output across the band. You know, it's like, when it comes to the Chinese transmitters, you know, they are absolutely, you know, nothing like this. You know, it's like, this is pretty immaculate, you know, compared to the Chinese. So anyway, let's take a little look at the spectrum here. So here's the spectrum. Alright, as we can see, the spectrum is not perfect, although it is pretty good. Okay, so let's see here. I'm gonna take the span, and let's span out first, just to make sure. Yeah, okay, so when it comes to harmonics, we're perfect. We're perfect when it comes to that kind of thing, okay? So now let's do some close-in analysis. Let me peak CF. And then we're going to span inwards here, and we're going to do some really close analysis on the carrier here. Yeah, so as you can see, this, you know, this stuff shouldn't be there. Okay, that is some noise. But it is very low down. Let me adjust this a little bit, because this is too much. We'll do that. That does look pretty good. Our span, you can see it right down there. Okay, so we're pretty close in here. So, let's see what we're on in terms of stereo mono. Yeah, we're on mono left plus right now. So, let's change that to stereo, and that will show us what we've got going on here. So let me press. Alright, we're going to change. Oh, there we go. Press. Now we're in stereo. And now we can see it has widened. Okay, so we just have to zoom in a little bit more here to verify that we've got the correct. Yep, there it is. As you can see, it's showing up there now. Showing up perfectly. We've got the center carrier, and then on either side we've got the 19 kilohertz, and then after that we have the 38 kilohertz. And it looks as if there is no RDS enabled at the moment. I believe I have, yeah, I think I turned that off at another time. So RDS is turned off. So, by the way, guys, I should mention, I made a mistake in my last video on the QN8007. I had said that, see, on the QN8007, there was another hump here and here, okay? And see, I had made a mistake on that video. See, I said that that must be noise or spurious or something like that. I was wrong about that, okay? I was wrong about that, guys. That was the RDS, okay? Turns out, RDS was enabled, and I didn't know, Okay, so that's why it was doing that. So actually, the previous transmitter, the QN8007, was actually putting out a perfect signal when it came to the close in on the carrier. The signal was perfect. There was no extra noise there, so I was wrong about that. The only noise in the Quintex signal is the phase noise or the noise skirt at the bottom of the carrier, but that's it. Other than that, there is no other erroneous signals, right? And as you can see, this carrier also doesn't have any erroneous signals, right? So very good. Now, let us, we'll zoom back out, and you'll see what it looks like as we slowly zoom out. So you can see, you know, compared to the QN8007 transmitter, right, there's not much of a noise skirt here. You can see this is definitely a cleaner transmitter. See, this is a true DDS transmitter. That's why we're getting better performance here. But, as you can see, it's still not 100% perfect, right? We still get a little bit of noise here. Okay, we're still getting a tiny bit of noise there. But it's minuscule, okay? It's very small. But, see, that shows you what the reason for buying, say, a Max Pro, the best one, the PLL VCO transmitter from PCS, the Max Pro. The reason you might want to buy the Max Pro is if you're really, like, just, you know, you've got to have it immaculate, you got to have it perfect. If that's how you want it, buy the Max Pro, and then you shouldn't have any of this here. It'll be just perfectly clean, like a spike, and nothing else, okay? So, as you can see, you know, again, DDS does introduce a little bit more noise than, you know, a traditional PLL VCO, but the noise is still less than the Quintex transmitter, the QN8007 transmitter, right? And the audio quality is perfect. You know, see, another one of these, like I said in my last video, it's not worth testing the audio because I know what it's exactly like. With the Quintex chip, it's exactly like the Chinese yellow transmitter or orange, whatever you want to call it, the 30 watter that I showed you guys in the last video, okay? Now, with this transmitter, it's also not worth testing the audio. Why? Because the audio sounds exactly the same as what you put into it, right? There is no distortion at all. See, this transmitter will actually take the audio all the way down to, like, I believe it's 0.1 hertz, okay? 0.1 hertz, right? So it'll do pretty much anything with no distortion, right? So you're going to have really good bass performance. So what I would say is, if you're, you know, like an audiophile, if you're a DJ and you're somebody that really likes bass, if you want your bass to be perfect with no distortion at all, you know, you want to have that very powerful bass without having any distortions, then you want to get this transmitter. Because see, any other transmitter that you could get is always going to introduce some kind of distortions into the bass. And both this transmitter as well as the Max Pro, you would want to get one of those two, okay? This one is probably the one you want to get because it's going to have the absolute best bass, okay? The second best bass would be the Max Pro series, okay? And then the worst in terms of bass would be the series with the QN8007, the one I just reviewed like a video or two ago. Okay, I have not reviewed the Max Pro yet, okay? I might end up asking PCS to send me another Max Pro because I had a Max Pro, but I gave that one away. And so if I could get another of their newest Max Pros, that would be great because then I could finally do a comparison of all three of their primary transmitter series or lines, I guess you could say. So yeah, so anyway, if you are like a bass fiend, then you definitely want to get this or the Max Pro. The Quintex, the QN8007 transmitter, is more of a budget transmitter, and you know, it doesn't sound bad by any means. It's just, you know, it might have a little bit of distortion in the bass. So anyway, I think we've done the spectrum. I've shown you the power output at the low end of the band as well as the high end of the band. The settings in the screen are almost exactly the same as what I showed you in the other PCS video that I did just a bit ago. So I don't think there's really, I'm not going to go into that again. But what I will do, because somebody said they wanted to see inside of these transmitters, and so I'm going to do that for you right now. Alright guys, I am back. I have opened up both transmitters here. This one is the DDS transmitter that we were just, checking out earlier. Okay. So this is what it looks like inside. So anyway, there is the screen module right there. There's the screen module. As you can see, it's got its beeper there, its real-time clock battery, ribbon cable. And now right here, here's the main board. So this is where everything takes place. As you can see right there, that's the final MOSFET. There's the low-pass filter. And then just a bunch of stuff. This is a very densely packed circuit board. And I am very impressed that they are able to like jam pack everything into such a small board like that without having interference issues and stuff like that. I'm kind of shocked, because you can see it's going all the way from that stage. I believe that is the DDS chip right there, that analog devices. I've always thought it's kind of funny how Analog Devices, Analog, right, is the company that actually makes DDS, which are digital, right? But anyway, so there's the chip where it's originating, right? And then the signal's coming out of there, getting amplified up through those little stages there, and then eventually onto that final MOSFET. And you can see there is an extra pad there where you could install a pair, right, a second MOSFET. Right, so they could operate, I guess, in push-pull maybe. And so for their higher power models, that's what they do. They make a model up to 75 watts, which is really nice to, have 75 watts contained, within a, such a small little case is really nice. It's really nice as a small standalone transmitter. So here's the audio input board right here. Oh, I should have shown the back of the DDS transmitter. I didn't show that yet. So on the back, we have the usual power connector right there, which is a barrel connector, of course. Then we have our BNC connector. Then we have a USB connector for USB audio. Then we have our AES and EBU digital audio connector. And then we have our analog left and right audio connector. And that is it. That is all we have on the DDS transmitter. So see, on the DDS transmitter, most of these features are not populated here. So this is the internals of the QN8007 transmitter. Okay, so this is the transmitter from the previous video. Okay, so this is what it looks like inside. And the ant is approaching. It's getting closer and closer to me. It's trying to, of course, make me, distract me from my video abilities here. But anyway, so here's the main circuit board right here. Okay, so we've got the final MOSFET right there, just like on the other board, right? Then we have our microcontroller there. And right down there, somewhere, yeah, right there, there it is. That is the Quintec chip. Hopefully I can get a good image of it. Yeah, it looks like they soldered it onto some type of breakout board there. You know, and I don't blame them. You know, it's like that chip is hard to solder. You know, that chip is really hard to solder. So it is, you know, honestly, I commend them for getting that on there. So yeah, you can see how they made that little module board there, that purple. There's a little purple PCB underneath it there. It's probably an Osh Park, I'm guessing. So yeah, and there it is. You know, it's a great board. Nice low-pass filter, you know, with the surface mount, pre-wound inductors, the dip switch there. So, of course, you know, if you wanted to, see, that's a huge advantage here. See, if you want to, you know, you can save a lot of money and just get this transmitter board and not get the whole box. You can just get this for a very, very, very low price, okay? And what you can then do is use the dip switches to control the frequency. And that way you don't even need a screen module or anything. You can just use this board, I believe. At least that's how it used to be with his older transmitters, so I'm assuming that it's the same way here. So yeah, but of course you're going to be very limited in terms of features if you do that. So it is really recommended to just buy the full transmitter in the box, you know. So yeah, and then you've got your audio input board here and some other expansion boards and stuff like that. So I already showed you the back of this transmitter on the previous video, so I don't need to show you again. But remember, the fan here is much quieter, I've noticed. However, it is mounted on the back, so that is something to be of note. See, on this transmitter, the DDS transmitter, see, they have the fan mounted on the underside of the metal chassis, the lid of the chassis, right? See, here we have the lid of this chassis, and there's no fan there, okay? It's just an intake vent. So they have their exhaust fan mounted here on the back, whereas this transmitter has nothing on the back and just has this, okay? The important factor is just that, you know, be aware, you know, there's something on the back here in case, you know, mounting, you know, maybe you don't have space or something, you know, note that that's there. Yeah, because that does jut out a fair amount. That does stick out a lot. So keep that in mind if you have space issues. And then also if you have noise issues, okay? If you have noise issues, you might want to go with this transmitter because it's a lot quieter with this fan. This transmitter is louder. Yeah, and I think also this board just needs a bit more cooling because there's a little like Raspberry Pi chip on there. So, you know, this board uses a fair bit more watts, I think, than this one does. You know, outside of RF stuff, just with the chips. This is a USB port, a USB-C, you know, like a standard modern phone connector port, where you plug in to update the firmware there. If you want to update the firmware that's on this chip, you plug in a USB cable right there. And what will happen is it will open up a virtual drive on your computer. You copy and paste the firmware file into your virtual drive that appears on the computer, and as soon as you paste the file, the drive will unmount. It'll disappear automatically. And that means that the chip has accepted the new firmware. So, success, okay? So that's that, and then if you want to update the screen module's firmware, which is a separate firmware than this, you update that through the front panel USB connector right there. Okay? So I had to do that, by the way, to enable the option for mono left plus right, but you won't have to do that. You know, the firmware is very full-featured and complete at this point. I have not noticed any problems or any errors, so there should be no reason for you to have to update the firmware, but maybe in the future there will be a new feature or something that you may want, and that's how you do it if you're curious. Okay, it's not too hard. It's not too hard to get it done, but it is kind of peculiar how you have to plug a USB cable in there and it appears as a mass storage device, and then you copy the file and all that. So anyway, that is about all. Okay, well, thanks for watching, guys. I hope you are enjoying these videos, and I'm trying to think if there's going to be any more. I believe there should be 1 or 2 more videos after this planned. Okay, so take care, guys. All right, bye.